Coming from working in CG animation and VFX and programs like Maya, what I found when I got into Unreal is that I really missed the shaders from offline renderers like the Arnold Standard Surface, the RenderMan Pixar Surface, and the Disney Principled BRDF. That's why I'm super excited to be releasing my Uber Shader master material on the Unreal Marketplace. The Uber Shader is designed to have the same familiar material attributes as these shaders, including, as you can see here, base color, specular, anisotropic, coat, sheen, emission, and subsurface scattering. In this demo, I'll begin by showing some example material instances showing the various surface appearances you can create with the Uber Shader. Next, I'll walk you through the Uber Shader's material attributes and how to use them. And finally, I'll show some additional special purpose master materials for doing things like translucent surfaces and UDIM texture mapping. So the way materials work in Unreal is that you have the material itself. This is also sometimes called a master material, and this is the one for the Uber Shader, and you can see it's got all these nodes and stuff in here. And from that you make material instances, and those material instances will just have this interface, which, as I was mentioning, is like paralleling the interface you'd have in something like the Arnold Standard Surface shader. And I have in here, in the content, under instances and then Uber, there's all these different example materials. These first three here, these are derived from the three additional master materials. So this one here is for virtual textures, this one here is for two-sided translucent materials, and this is for thin glass. And we'll come back and look at these sort of special purpose materials later on. But all the rest of these are made from the Uber Shader. And you can see that there's just all sorts of different looks that you can get. We've got here tangent mapping to get kind of that brush steel look. Here we've got two types of car paint shaders, this one with metallic flakes and this one here with sort of a two-tone paint. Then we've got anisotropic metal here. Here's metal with sort of a scratched surface. Back we've got again sort of a dielectric material with again a scratched surface. Over here are examples of the different effects you can get with the clear coat. This one here is where the normal is the same for both the lower and the upper levels of specular, and then over here we've got the flatness on so that you get sort of this classic bumpy surface covered by a smooth surface. Then here we've got aluminum foil, gold. Over here are three different examples of cloth materials. So here's a silk, this is a velvet, and this is a knit cotton. Then we've got back here, there's three examples of subsurface, skin, snow or ice, and wax. In the back here we've got some examples of glow. As you can see, there are a ton of different surface appearances or looks that you can create with the Uber Shader, and that's what makes it such a powerful tool. With that in mind, let me walk you through the Uber Shader's parameters or material attributes and how they work. Alright, so we're going to go over all of the parameters in the Uber Shader, beginning here at the top with the base color section, and we have in here the base color map, and then you have here an override color map, and so that's where you can, instead of using a texture map, you can just use a swatch color in there. This is really nice to be able to do this when, say, you want to just check out the bump map and not be distracted by having the color map on top of it. Look at things in isolation is a really nice technique when doing look dev. Just have that flexibility. Then we have here the base weight, and that's just a multiplier, so you can just darken down your texture as desired. Then below that we have the metalness section. We have the metalness weight, which is defaulting to 1. And then we have the override metalness map in ORM. So the metalness is going to be coming from the ORM map, which is down here. That's a packed RGB channel map, and the M in ORM stands for metal, and that's what's going to be driving this by default. And of course our frog is not metal, so there's no metalness map for the frog. If you want, you can override that, and it will then make it metallic. So let's make a metal frog real quick. So I'm going to override the color map, come into here, make that bright so it's really reflective, and then I have a steel frog. Then I could put some color into it, and now I have a gold frog. And then below that we have the color corrections. First one here is tint, where you can tint the color of your frog. We have desaturation. This is at 1, the default is nothing, and then as we lower it down we can of course desaturate it. Gamma is sort of a subtle way to do contrast, so if I raise the gamma then I get kind of an albino frog, and if I lower the gamma then I get it contrasty. And the saturation is nice to use in combination with this, because as you lower the gamma and get more contrast, this increases the saturation, and so to compensate for that we can kind of pull it back down to get our desired look. And then we have offset color. That's where you can add a color into it. This basically lifts the blacks in the image. A good example of the use of the offset color is here on this crushed velvet material. I have a black and white map going in here just to get kind of the color variation in here. And what I'm doing is I'm using a combination of the tint and the offset color. So it comes in like this, and then we put the offset color into it to lift up the blacks to whatever kind of proportionality we want to have, and then we put the tint into that, and then we can put back on the metalness. And then at the very top here we have disable color correction, so I can just click on this and it will disable all of the stuff that I've done in the color correction section here. And again, that's just nice to have as a toggle that you go back and forth so you can see what you're doing. Next we have here the bump section. This is reading in a normal map here, and we can come to the height and raise the height, invert the height even. It's pretty straightforward. Emission is again kind of ridiculous for a frog, but this will read in the emissive maps if you have any. In this case we obviously don't. There is again the override emissive maps option, and this just puts in a color. We need to turn the emissive multiplier on because it's set to 0, so put it to 1. There's an emissive tint. That makes more sense when you have, say, like a mask or something and you want to modify that map. So for example, this has a map going into the emissive color and it's black and white, and I'm tinting it with a blue so I get kind of a bluish glow off of the white. You can also see that the multiplier here I have it up to 50, so you can get like really strong effects with it. Let's go up to 1,000 and we get like really luminous and bright. Next up is the sheen. Here on this car paint shader, I'm using the sheen to get a two-tone car paint, where sheen it works with glancing angles or the facing ratio, so that things that are pointing away from the camera normal are going to have a different color, and that's exactly how the sheen works on here. So you've got the sheen color, the sheen roughness, and the sheen weight. And so if we just jump into this shader here, the sheen color, I can change that. And here, so we can see it better, I'm going to turn off the metalness weight on this so you can just see more clearly how it's blending together. So we have the sheen color. That is any color you want to put into this. So just flip it around to something else. And you can also, of course, have it be white. You can even have it be black. We'll come back to another example of that in a second. The roughness is the way the blend works. So 0 is, you can see here as I roughen it up, it's going more and more in. So it'll be easier to see with white. So it's like really subtle here, just barely on the edges. then going more and more in. The primary place where you're going to be using sheen is in materials like cloth here. We've got these three examples. This first one is sort of a silk, and as you can see here, what's happening with the sheen is going to black. And then on top of that, cloth has a colored specular highlight as its property, and in Unreal we need to do that with metalness. So we've got in here, in addition to the sheen, we've got a anisotropic highlight, and we've got a certain degree of artistic metalness, because obviously cloth isn't metal, but it does have those kind of colored highlights. And then finally we have some maps that we're using, that I'm providing for you guys to play around with. Those maps are here in the texture examples, and I've got this here. I'm using a twill on this, and then there's also on this example over here, there is a knit fabric example. Both of these maps are made by modeling the geometry and then rendering a depth map so that you get proper depth information onto these, and then those are going into the base color, and then I tint that and offset it so I lift up the blacks a little bit with the offset and get a nice mix to go into there. And then, as I mentioned, have like a certain amount of metalness with like generally pretty rough specular highlights. Over here we have an example of kind of a crushed velvet, and again we've got the sheen going across here. Here the sheen is brightening up the edges, and then finally we have kind of knit cotton material, and has a much more subtle kind of sheen, like a sort of like, you want on those kind of things to have it be like barely noticeable. Let's next take a look at the specular section. Alright, so we've got here at the very top, convert packed map color space to raw. And if you look at this packed map here, you'll see it's set to sRGB. So you want color maps to be set to sRGB. You don't want normal maps to be set to that, and you also don't want a packed map, which is used as a mask. You don't want that to be set to sRGB either. And that is what this does here. This will take an ORM map that has sRGB checked on it and convert it back into raw. In some cases, for example with Megascan's textures, it is unchecked, and in that case you don't need to have the conversion, you could just turn it off. Then below this we have enable occlusion, and that is off by default, but if you want to have occlusion or cavity maps in there, then you just toggle that on and it'll work just fine. Below that we of course have the ORM map itself. Then below that we've got specular weight, 2 roughness values, and index of refraction. So the index of refraction defaults to 1.5. That's kind of what you want for most dielectric materials. For metals, it's not even taken into account anyway. It does a different calculation for metals. So generally just leave that alone, but it's there if you want to have it. The valid ranges are between 1 and 1.8. The specular weight is a multiplier, so you can just completely eliminate the specular from your object if you want to, and then conversely you can come over to the base weight and crank that down so you're seeing only the specular contribution. And the idea with both of these is that it's useful when doing look dev to be able to temporarily see the different components of the shader in isolation. With that in mind, let's next look at roughness. So you can see here that we have in the ORM map, the roughness has different values in a mask, and that allows us to dial in with our 2 roughness sliders different kind of looks for things. Below that we have the anisotropy. So it's pretty straightforward. You've got the anisotropy control itself, which when it's at 0, it's going to just be a regular isotropic highlight, and then it stretches out as you go in either direction. And it also has a rotation on it, so you can spin it in a complete rotation around. And then below that we have use tangent map. That will replace the rotation with this tangent map. And so I have in here a sample map. You can feed it into it any map you want. It uses vector-based maps, with the RGB channels, or rather the R and G channel. And it's important here, I have this note that it's important that you have these as EXRs as opposed to like an 8-bit PNG, because you're going to get banding otherwise on this. And then when you have that selected, you've got the tile tangent map and the rotate tangent map controls. The specular coat section is pretty much a parallel to the regular specular section and kind of primarily acts as a secondary specular lobe. So we've got the coat weight, the roughness, the coat normal flatness, which I'll come back into a second, and then the coat IOR. And with the weight, you can set that to 0 or 1 to kind of dial in, just sort of isolating it out as I've been speaking about. So right now I only have the specular weight on, and I have this combination of these two roughness values modulated by this ORM map going into here to get these different regions to get different values onto here. And if I turn this off, then it just removes it completely, and we can see what I'm doing with the coat, which is that I've got kind of a pretty rough looking broad highlight across the whole thing. And when I combine it together with the specular, then that allows me to get a pretty nicely complex specular highlight. So in other words, the normal map is affecting both the specular highlights and the coat highlights. And if I turn on the coat flatness, that will then make it so that the normal map does not affect the coat specular. And it looks kind of weird here because I have the highlights on really rough, but if I take it down, I get kind of this sort of glass covering over the whole thing. Last but certainly not least is the subsurface scattering. So you'll see here that we have a note here that SSS disables metal coat and anisotropic. That's a limitation currently in Unreal. So you'll see that those sections, when I click on this, are going to disappear. And then we get our subsurface scattering. This is using a subsurface profile. So SSS profile and material property overrides below. So if we scroll down here to the material property overrides, we see that there it is. And if you click on this here, you'll see that these are in the utilities folder, and I've got a generic subsurface profile that it just puts on there initially. There's also, I have in here one for skin, one for snow, and one for wax. Those are in the examples that I was showing you before, using those profiles, and of course you can create your own profile. Finally, at the very bottom here, we've got the UV controls. We've got rotate UV, the gang tile that is going to combine together the U and the V to tile them at the same time. If I uncheck that, then it will give me the U and the V tiling separately of each other. And then we have also the offset U and V. But at the very top here, we have separate UV controls for each map. So let's look at a case where we might want to do something like that. So I'm going to check this, and when I do, the UV controls are going to disappear from here, and they're going to appear under all of the different map types. So they can be under the specular, the bump, the emission, and the color. So what I'm going to do is I want to put in a map into the normal here. Here I have a Carflake map. I'll just drag that into here. And this is way too big, so I want to tile this, but of course I don't want to tile these little flames here in the color map. That's why it's nice to have these UV controls separated from each other for granular control. Let's take a look at the different master materials in addition to the Uber shader and what they're used for. So on the master materials here, we've got 4 master materials. We've got the main one, the Uber shader. We've got the Uber shader VT, that's for doing UDIM maps or virtual textures. We've got one for doing foliage, which we'll come back to and take a look at in a second. And then right now what we want to look at is the glass one. And so what I'm going to do is I'm going to select the car and I'm going to go to the material for the glass. I believe that's called Windows here. I'm gonna double click this, and then I'm going to come down into here into the parent material, and I'm going to drag in the glass thin shader into it, and then that basically swaps out the interface here, so I can change the master material that's driving this. Now we can start just sort of looking over the material. You can see that it's similar to the Uber material in that the base color section, the bump, the specular are all very similar. And then of course what's different is it has the transmission section. So for the blinker, let's go to the transmission color and make that orange. And notice that the highlight is not orange because it's a correct dielectric highlight, and it's only the transmission that's being affected. We can mess around with the roughness here, maybe make it kind of cloudy by coming into the transmission weight and lowering it down a little bit. I'm going to put some color into the glass color as well. And you can see how on the headlight here we have sort of a bump pattern. That's actually coming from the geometry, but you can put in a bump map as well into the shader. So here I put in sort of just a default tile. I'm gonna make that a little bit, tile that a few more times. Yeah, that's pretty much it for the glass shader. Let's take a look at another of the special purpose materials, the Uber Shader VT. VT stands for Virtual Textures, and that's how Unreal works with UDIM maps, which you can see I have here on this frog. All right, so I have loaded in here the Uber Shader VT, and under the properties, I'm loading in the UDIM maps. I import this in. And if we read in our frog, we see that the texture maps are not working currently. And we need to do a couple things to get them to work. One is that we need to convert these to virtual textures. In the project settings, if we look under virtual textures, I have enabled virtual texture support, but I don't have enabled virtual texture on texture import because I don't want every map to always map in as a virtual texture. So it's not on by default, so we just need to manually select it, which is not very hard. You just come into here and say convert to virtual texture and say OK. And these are all now virtual textures, and you can see it's displaying on the frog, but it's actually only reading in the first map here. It's not reading in all the maps. And if you look at this here, you can see it's just one single map. So what we need to also do is again select all the textures here and say re-import. And now it's read in all of the maps and they are tiled across the frog. Awesome. Let's next take a look at the foliage art material. Art stands for alpha, roughness, and translucence. And I have here a Megascans asset to kind of demo this. And the controls are really parallel to the Uber shader in the sense of the base color corrections, the bump map, the specular controls, but the difference is the ORM map is not ORM, it's ART, alpha, roughness, and translucency. And so alpha is for the mask, the kind of cutout mask. Roughness is for roughness, like before. And the translucency is for the way that the light goes through the leaves here. And by default, it's set to 2 to give you, kind of luminous looking bright leaves. Looks really nice, I think. Of course, you can put it back down to 1. Maybe it's a little more realistic, but not as pretty. And there's also a tint and a desaturation node on that. Yeah, that wraps up the overview of the Uber shader. Let me know in the comments if you have any questions, and go click the link in the description and get yours on the Unreal Marketplace.